Hi everybody, today we're going to be talking about conditional statements. By the end of this lesson, you should be able to identify the parts of a conditional statement called the hypothesis and the conclusion. You should be able to write a statement that's not already in that form in conditional form. You should be able to determine the truth value of a conditional statement, to write the inverse, converse, and contrapositive of a conditional statement, and finally, you're going to be able to determine whether or not two conditional statements are logically equivalent. So that's a lot to cover, so let's get started. Well, first thing we need to know is, what is a conditional statement? Well, a conditional statement is just a statement that has an if followed by a statement, and then a then followed by another statement. So for example, I might say, if today is Monday, then I have soccer practice. And a conditional statement is made up of the hypothesis, which comes after the if part, and the conclusion, which comes after the then part. So in my statement, today is Monday would be my hypothesis, and I have soccer practice would be my conclusion. And since we're always trying to take shortcuts in math, we often just write a conditional statement with P being the hypothesis and Q being the conclusion. So we might refer to a conditional statement as an if P, then Q, meaning if this P hypothesis, then this Q conclusion. You will also see it written as P implies Q. So this and this mean exactly the same thing. If P, then Q is the same as P implies Q. We can also read this second one as if P, then Q. So let's practice identifying our hypothesis and conclusion in our own statements. Here's an example. If it is raining, then it is cloudy. So we want to identify what is the hypothesis and what is the conclusion. Well, the hypothesis just comes after the if statement. So I can underline the hypothesis, it is raining, and the conclusion, it is cloudy, and I have identified the hypothesis is just it is raining. And the conclusion is just it is cloudy. And you'll notice that the if and the then are not part of the hypothesis and the conclusion, but only indicate where it is. So pause the video for a moment and see if you can identify the hypothesis and the conclusion of the statement, if a polygon is a square, then it has 4 sides. Okay, well, I guess you've restarted, so let's see how you did. Well, after the word if, you see polygon is a square, so that is our hypothesis. And after then, it has 4 sides, so that is our conclusion. And just to make sure that our reader knows exactly what we're saying, I'm going to say the hypothesis is a polygon is a square, but just to clarify for the reader what the conclusion is, I'm going to say that our conclusion is the polygon has 4 sides, just to clarify what I mean by it. And that's it. So the next thing we need to learn how to do is write a statement in conditional form if it is not given that way. So here's how we do that. So in this case, we are writing a statement in conditional form that's not given in conditional form. So for example, if I take the statement, all dogs go to heaven, we can rewrite that so that it's in the proper form. So let's take a look at this statement. It's saying that all dogs go to heaven. So I need to see something about if an animal is a dog, what happens to it? Well, it just goes to heaven. So I'm going to say if an animal is a dog, then it goes to heaven. I don't know how many of you saw that movie. It was from a long time ago. Cute movie. We really want to be careful here that we're writing in coherent English. So it wouldn't make sense to say, if dog, then go to heaven. We really want to make sure that when we are rewriting statements in conditional form, that they make sense when we write them. So if an animal is a dog, then it goes to heaven. So let's try another one. If a number is divisible by 5 if the last digit is 5 or 0. So this one's actually written backwards because we see that the if is right here. So this is saying if the last digit of a number is 5 or 0, then it is divisible by 5. So that's a little bit different. So the if is kind of your clue here that what follows it is the hypothesis. So if the last digit of a number, because we can't just say if the last digit, that doesn't make sense. If the last digit of a number is 5 or 0, 0 or 5, then it, or the number, is divisible by 5. Okay? Why don't you take a try, pause the video for a moment, and write the conditional version of the statement, the sum of the measures of complementary angles is 90 degrees. Okay, hopefully you've given that a try, and now we will see how you did. So first of all, we should have started with just our standard if, and then a then, so that we know we're going to put a hypothesis here and a conclusion here. Let's see. The sum of the measures of complementary angles is 90 degrees. So if the sum of two angles, or two angle measures, is 90 degrees, then the angles are complementary. And this one you actually could have written the other way as well. You could have said, if two angles are complementary, then their sum is 90 degrees. And we'll talk a little bit more about that later. But really, this is how a definition works. If it goes both ways, we call it the definition. So we know that the sum of two angle measures is 90 degrees. That makes the angles complementary. And in fact, we could also say, if two angles are complementary, then their angles add to 90 degrees. So if you wrote that, that's also correct. So I want you to take a look. We're going to talk about finding the truth value of a conditional statement. So once we know what a conditional statement is, we want to be able to determine whether or not that statement is true for different scenarios. So we talked about truth tables last class and the class before. And we really want to be able to create a truth table for a conditional statement. So I just want you to pause the video for a moment, write down what you think the truth value is for each of the statements below. And remember, at the beginning of this unit, we talked about how we show a statement is false by finding a counterexample. So see if you can think of counterexamples to make a statement true or false, and then we'll talk about it. So thank you for pausing the video and making sure that you read through these statements before you continue. So let's look at this first statement. If you subtract a whole number from another number, so I see this word if, I know that the next part is going to be the hypothesis. You subtract a whole number from another whole number, then the result is a whole number. Well, I'm going to need to know a couple of things here. First of all, a whole number does not include the negative numbers, so that's kind of the trick here. So if you remember that whole numbers are the positive integers, then on the positive integers and 0, then we can think about whether or not we can think of a counterexample. Well, let's see. If I subtract a whole number from another whole number, well, let me just try. What about 7 minus 5? Well, that gives me a whole number. So I have met the hypothesis. The question is, did I get a whole number? Well, that one works. If I do 32 minus 18, yep, that'll still work. What if I do 18 minus 32? Well, if I'm subtracting a whole number from another whole number, so I have met the hypothesis part, but does that result in a whole number? Well, in this case, it doesn't. So this is my counterexample. This tells me that this statement is a false statement because I could come up with a counterexample where I met the hypothesis, but the conclusion did not hold. And that's really what makes a statement false. A conditional statement is false when you meet the hypothesis but not the conclusion. So let's look at the next statement. If last month was February, then this month is March. Well, if last month was February, if I meet this requirement, does the next month have to be March? Well, yep, that's the way our calendar works. So if we meet this requirement, this will always follow. So if this is true, then this has to be true, which means given a true hypothesis, our conclusion is true. That makes this a true conditional statement. Okay, so now we get to the really tricky situation. Here, it says, if Miss Trautman wins the lottery, then she will buy Ellie a car. Well, how do we determine whether or not the hypothesis is true? I mean, this is kind of tricky. So what makes a conditional statement true? What makes a conditional statement false? And this we really need to explore a little bit more. So let's see if we can make a truth table to analyze this statement. If Miss Trautman wins the lottery, then she will buy Ellie a car. Okay, so here we go. Let's figure it out. We've got if Miss Trautman wins the lottery, so that is our hypothesis P. Then she will buy Ellie a car. That is our conclusion Q. So we've got 4 possible scenarios here. We could have Miss Trautman wins the lottery. That would be awesome. And she could buy Ellie a car. Well, if she wins the lottery and she buys Ellie a car, then the conditional statement is true, right? We have the hypothesis being met. We have the conclusion being met. So as long as Miss Trautman wins the lottery and buys Ellie a car, we would say that that statement is true. Well, what about if Miss Trautman wins the lottery, but then she doesn't buy Ellie a car? Well, that's no good. That would make me a liar, right? That is no good. So here, if I actually win the lottery, but I don't buy Ellie a car, this is what would make that statement false. And in fact, this is the only way to make this statement false. If my hypothesis isn't met, then I don't care what happens with the conclusion, right? If I don't win the lottery, then it doesn't matter whether or not I buy Ellie a car. This doesn't matter. So if I don't meet the hypothesis, then the statement is automatically true, which is a little bit unintuitive. But if we don't meet the hypothesis, we really couldn't have been lying. We really can't make a false statement if we don't meet that first part. So that automatically is true. So we have true for the first scenario. I win the lottery and I buy a car. We have true, because I didn't lie, if I don't win the lottery. The one thing that could make me a liar, the one thing that could make this statement false, is if I do win the lottery and I don't buy Ellie a car. So let's look at this, let's kind of analyze this next question. If x is a positive number, then 10x is greater than x. Well, if x is a positive number, that means I have to meet this scenario in order to determine whether or not the statement is true or false. So I am only considering positive number x's. So I might try 1, I might try 1.3, I might try 18.6, some random positive numbers. These are positive numbers if I multiply them by 10, so I have to have the positive number. If I multiply them by 10, do I get a number greater than x? Well, 10, 13, 186. Looks like this holds true, but notice that I had to meet the hypothesis first. If I hadn't, let's say I had picked, let's let x equal -3. Well, then I would get -30, but that doesn't matter. This scenario is not considered in determining the truth value of this statement. We only consider it when we start with a positive number. So we would say that this statement is true. And in this next scenario, again, if you live on the moon, we would have to meet this hypothesis before we even worry about the conclusion. Well, you don't live on the moon. So since this is false, it makes the statement true again. So the key here is that the only way to make a conditional statement false only when the hypothesis is true and the conclusion is false. That is the only possible way to make a conditional statement false. So far, we have identified the hypothesis and conclusion of conditional statements, we've written statements in conditional form, and we've also been able to determine the truth value of a conditional statement. So those are the three objectives that we've covered so far, and you should take a moment at this point and write down any questions that you have for class tomorrow, especially with regards to the truth values of the statements, because that's a little bit complicated. So we'll definitely take some time to review that in class. But right now we're going to talk about three more vocabulary words: the converse, inverse, and contrapositive of a statement. And really, these words are just ways to write the statement, rearranging the hypothesis and the conclusion. So the first one, the converse, is just if we take the hypothesis, in this case, an angle measures 35 degrees, and the conclusion, the angle is acute, and we switch them. So if a conditional statement is P implies Q, or if P then Q, which means exactly the same as if P then Q. If that's what we start with, then the converse is just the flip of that. We take the conclusion and we say that that implies the hypothesis. In other words, if Q, then P. And in order to write a converse, we have to be given a conditional statement. So in this case, we're given the conditional statement, if an angle measures 35 degrees, then it is acute. So we really need to make sure we've identified the hypothesis, an angle measures 35. We've identified the conclusion, it is acute, and we're going to rewrite this, making sure that it makes sense in English. So I'm flipping it. This time we're saying if an angle is acute. If an angle is acute, then an angle measures 35 degrees. And let's not worry right now about the truth value of this statement. We're just practicing writing the statement itself. So we want to make sure it makes sense in English. I'm not going to write if it is acute. That doesn't make sense. I'm going to say if an angle is acute, then it measures 35 degrees. And if you're kind of making a questioning face right now, that's totally appropriate, because that should definitely ring some bells for you in the truth value category. Okay, we will talk about that on the next page, I promise. But the converse here would just be of this statement, if an angle is acute, then it measures 35 degrees. So converse just flips the P and the Q. The inverse negates the P and the Q but doesn't change the order. So the inverse of a statement is, and we write it, remember, from the truth tables, not P implies not Q. Or if not P, then not Q. So in this case, our P was if an angle measures 35 degrees. So the opposite of that is an angle does not measure 35 degrees. So if an angle does not measure 35 degrees, then not Q. The opposite of it is acute is it is not acute. And remember from the last unit, we don't want to say it's obtuse or it's right, or we don't want to kind of give a list. We just want to make it really simple and say it's not acute. So if an angle does not measure 35 degrees, then it is not acute. And again, you should have some raised eyebrows as to the truth value of that statement, but that is indeed how you write the inverse of the statement. And then the last one is called the contrapositive. And the contrapositive of a statement is the opposite of Q, or the negation of Q implies the opposite or negation of P, the hypothesis. So in this case, we would say if not Q, then not P.